Welcome to Golden Software's video training for Grapher 12. Grapher is a powerful 2D and 3D graphing software package. In this video, I will briefly explain the different graph types available in Grapher. Grapher has over 70 types of plots that can be created depending on the type of data you have or how you want the data displayed. The types of plots are grouped into 7 categories: basic, bar, polar, ternary, specialty, statistical, and contour surface. These can be seen in the Create section of the Graph's Ribbon Bar tab. Basic plots are used to display lines, points, and bubbles in 2 or 3 dimensions. These can be created by clicking Graphs, Create, Basic, and choosing the plot type you wish to create. The sample file, basicgraphtypes.gpj, shows examples of each of the basic plot types. Among others, these include line scatter plots, step plots, bubble plots, and 3D XY function plots. Line scatter plots are used to display symbols at specific data locations and connect those symbols in the order they appear in the data file with the shortest line possible. Multiple line scatter plots can be added to one graph to display multiple data sets at one time, and you can display only the symbols, only the lines, or both. This plot type is available in 2 and 3 dimensions. Step plots display lines from data point to data point like the lines of line scatter plots, but the lines are drawn parallel and perpendicular to the axes rather than directly from one point to the other. This plot type is also available in 2 and 3 dimensions. Bubble plots display symbols at point locations like the symbols of line scatter plots, but the size of the symbol varies with the value of a data variable. All symbols can be the same color, or the color can be determined from a worksheet column, as the example shows. This plot type is also available in 2 and 3 dimensions. As we've seen, most of the basic plot types can be displayed in 2 or 3 dimensions. 3D XY function plots are the 3-dimensional equivalent of XY function plots. Function plots do not require data, but instead plot a line or plane based on a defined mathematical equation. Function plots can be created using a mathematical equation, where x is a function of y, as this example shows. Other function plots, available in both 2 and 3 dimensions, show y as a function of x, and show a parametric function where both x and y are functions of another variable, t. Bar charts are used to display bars or floating bars in 2 or 3 dimensions. These can be created by clicking Graphs, Create, Bar, and choosing the plot type you wish to create. The sample file, bargraphtypes.gpj, shows examples of each of the bar chart types. Among others, these include vertical bar charts, horizontal floating bar charts, and 3D XYZ vertical bar charts. Vertical bar charts display data as a bar extending from the base value up or down to the data value. This information can be displayed horizontally or vertically, on an axis displaying numerical values, as shown here, or text values. Floating bar charts display the bar as a difference between 2 values. For a horizontal floating bar chart like we have here, the bars are plotted between an x minimum value and an x maximum value for each y value. 3D XYZ vertical bar charts plot bars up or down to a specific data value like with vertical bar charts, but the bars are 3-dimensional and are located at an XZ location rather than just an X location. For all but the floating bar charts, you can add additional bar charts to the graph and display new bars stacked on the existing bars, adjacent to the existing bars, or some combination of the two. Polar graphs are used to display lines, points, and bars on polar axes. Polar data is defined by an angle and distance from the center of the plot. Polar graphs can be created by clicking Graphs, Create, Polar, and choosing the plot type you wish to create. The sample file, polargraphtypes.gpj, shows examples of each of the polar graph types. Among others, these include polar line scatter plot, rose diagram, and wind chart. Polar line scatter plots display degree, radian, or grad data versus a radial distance. Like the basic line scatter plots, multiple plots can be added to a single graph to display multiple data variables at once. Rows diagrams display data in groups or bins, where each bin represents the number of occurrences of an event that falls within a specific angular region defined by the bin size. Rows diagrams are similar to histograms in the 2D XY graphs. Wind charts typically display wind data, though other data types can be represented on a wind chart. Like the rows diagram, data is grouped into bins, but here each bin represents the number of times wind flows from a given direction. The direction is divided up into bins, and each bin contains separation of the data into wind speeds. Ternary graphs are used to display relative percentages in a three-component system. These are commonly used in chemistry and the earth sciences to display chemical compositions and rock classification schemes. Ternary plots can be created by clicking Graphs, Create, Ternary, and choosing the plot type you wish to create. The sample file, ternarygraphtypes.gpj, shows examples of each of the ternary plot types. Symbols, lines, or symbols and lines can be displayed on a ternary plot, and symbols can be grouped into classes or displayed as bubbles that are grouped into classes. Additionally, multiple ternary graphs can be combined to form a Piper plot in order to analyze ion concentrations in groundwater. Specialty plots are used to display data in different ways that do not fit other plot type categories. These can be created by clicking Graphs, Create, Specialty, and choosing the plot type you wish to create. The sample file, specialtygraphtypes.gpj, shows examples of each of the specialty plot types. Among others, these include candlestick plots and two-point vector plots. Candlestick plots are used mainly to display the daily high, low, opening, and closing stock values, although other data types can be used. These plots draw a vertical line between the high-low values and display a box between the opening and closing values. The color of the box represents whether the stock value rose or dropped that day. Grapper can create a variety of 2D and 3D vector plots from different input data. Two-point vector graphs draw vectors between two xy points in a two-dimensional graph, but other vector plots draw vectors using a starting xy value and an angle in magnitude. The type of the vector plot is shown in the Property Manager. Statistical plots are used to display statistical properties of the data in 2 or 3 dimensions. These can be created by clicking Graphs, Create, Statistical, and choosing the plot type you wish to create. The sample file, statisticalgraphtypes.gpj, shows examples of each of the statistical graph types. Among others, these include vertical histograms, horizontal box whisker plots, and 3D pie charts. Histograms are used to display the data in groups of bins. The number of bins represent the range of data, while the height displays the total number of data points within the range. Histogram bars can represent count, or relative frequency, cumulative count, or cumulative relative frequency. Histograms can be plotted vertically, as shown here, or horizontally, and in 2 or 3 dimensions. Box whisker plots are used to show minimum, maximum, median, lower, and upper quartiles for a data set. They can be displayed horizontally, as we've shown here, or vertically, and they can be notched in the middle, indicating confidence in the statistics. Outlier data can be displayed if desired as well. Grapper can create solid pie charts, as is shown here, and hollow donut plots in 2 or 3 dimensions. Each pie slice represents a variable, and the slice size represents a proportion of all data that the variable makes up. Contour surface plots are used to display 2 or 3-dimensional contour or surface maps from a data file, a grid file, or a mathematical function. These can be created by clicking Graphs, Create, Contour Surface, and choosing the plot type you wish to create. The sample file, contoursurfacegraphtypes.gpj, shows examples of each of the contour and surface map types. Among others, these include XY contour data maps, XZ contour function maps, and surface grid maps. Contour data plots are created by gridding data files with the inverse distance to a power interpolation method. These can be displayed in either the XY plane, as is shown here, or in the XZ plane. When shown in the XY plane, it is the Z variable that is interpolated, and thus it is lines of constant Z values that are represented by the contours. When shown in the XZ plane, It is the y variable that is interpolated, and so lines of constant y values are represented by the contours. Gridding properties are viewable and editable from the gridding page in the Property Manager. Like with function plots, Grapper can create contour maps from mathematical functions, and like with contour data maps, these can be in the XY or XZ plane. This example is in the XZ plane. Surface grid maps use existing grid files to create a 3D surface. The surface can have a solid color or a gradient fill applied, and can have mesh lines displayed in varying frequencies in either both the X and Z directions. This concludes the video training for graph types of Grapher 12. If you have any additional questions, please contact Golden Software.